Okay, so we're going to start this week by reviewing what we introduced last week, which was the concept of explicit and recursive sequences. And to start off, there are common things between the two types of sequences. This concept of A. A is a starting value in some input-output chart. It's the same concept for explicit, and it's the same concept for recursive. And what you're going to want to do is start out by just writing what the starting value is. And so our starting input is 1, and our starting output, which is our starting value, is 3, okay? The second piece of these two sequences also applies to both. This concept of D. And D is equal to the common difference. And again, this does not mean subtraction. Difference means how much is it changing from term to term. And so from term 1 to term 2, it changed 7. From term 2 to term 3, it changed 7. And you can see that this pattern is going to repeat. And so what we have is we have a common difference of 7. And if we're going to write these rules, we now have all the information that we need. And so don't overthink this. Don't try to plug things in. Again, that works for explicit, but that is not the case for recursive. But if we're going to write our explicit rule, we have our starting value, which is 3, plus our common difference, which was 7, which is multiplied times this n minus 1. Now, recursive is a little different. Recursive, you have to separately write what your first value is, because remember, this is a positional type of concept. And so the position in a sequence of terms is what matters. It's not as straightforward as the explicit formula is. And so we write our first term as f of 1 is equal to, and I made a mistake, so this is equal to 3. So forgive me for that. And the second part, what is important to remember is that this never changes when we're writing a recursive rule. We're going to write that every single time, because what that means is that the term we want, f of n, is equal to its previous term plus or minus whatever the common difference happened to be, and in this case that was 7.